Hi, and welcome back to another video. So last time we looked at aldehydes and ketones and how they react and what the differences are between those two. And today we're just going to do a quick video of how to test for them. So both of them are colourless. You don't really know, you can't see a physical difference between the two, but when you do a chemical test for it, you can kind of identify them based on the fact that aldehydes get oxidized quite easily to become carboxylic acids and ketones don't get oxidized. So the three things that we're going to look at, or the three chemicals that we'll be looking at, is either Tollens solution, Fehling solution, or Benedict solution. And the two, the good way to remember it is the Tollens solution turns silver, so it's like a silver mirror experiment, and then the two others, the Benedicts and the Fehling solution, are blue solutions that turn red. And all of them actually just change colour or change appearance with aldehydes, and nothing happens with ketones because ketones can't get oxidized, but with aldehydes they turn into carboxylic acid. Okay, so if we have a ketone or an aldehyde, and remember the aldehyde is the double bond at an end, so this is going to be called propanol. We're adding, the first one that we'll be looking at is Tollens solution or Tollens reagent. And the Tollens reagent is a reagent that has diamine silver complex solution in the solution. So we have silver and we have ammonium. And then we have the two there, for instance. So this whole thing has so you don't really need to know, you just need to know that it's silver ions. And what happens is this oxidizes that to become carboxylic acid, so we'll put that one down there. And then what is happening with this silver is it becomes a solid or precipitate, a silver precipitate. And when that happens, whatever the silver is touching, like the glass that we're using to do this this will form a silver coating on the glass surface. So it's going to become a mirror when it's an aldehyde and it actually reacts. If it doesn't react, it is just a black, very dark black grey colour, the liquid, and it just stays like that. So that's the first one. So the first test for an aldehyde, a positive test, is called the silver mirror test. And what happens is silver oxide, or this diamine silver diamine complex oxidizes the aldehyde to become carboxylic acid, and then what is left is the silver, and the silver then coats the mirror or the glass. That's the first one. So the next one is called Benedict. And we can put Fehlings as well, because both of them are pretty much the same solution. Okay, and what happens is they start with, so if I have an aldehyde, so propanol, what I have is a solution that has copper ions in it. Okay, and we all know that copper ions are blue to start with, and when that reacts, when that gets oxidized, the aldehyde will become a carboxylic acid, and then what we have left is copper oxide. And this copper oxide turns from a blue color in solution to a brick red, orangey, like a dirty red color. So with Benedicts and Fehlings, a positive test with an aldehyde is the color will go from blue to copper oxide that's red, because it'll oxidize the aldehyde. If it is a ketone, the ketone won't get oxidized and the solution will stay blue. So the three ways to test for an aldehyde or distinguish between an aldehyde and a ketone is either Tollens solution that forms a silver mirror, because it liberates the silver that's in the silver diamine complex. So the first one, Tollens, silver mirror effect, or you have Benedict's and Fehling solution that goes from blue to brick red. And all of them are positive will test positively in an aldehyde or change colour in an aldehyde, and it'll stay the same in a ketone because they don't get ketones can't get oxidized. Okay, so quick video on how to distinguish between aldehydes and ketones.
Chemistry, baby,